Hey everybody, here is where the fun begins now, this last third, and that is actually drawing graphs on a polar grid. All right. You guys have had experience in your high school careers with lines on a grid. You had the old parabola on a grid. Remember, we had our sine and our cosine functions on the grid. Now we're going to put everything on the polar grid now and see what that looks like. All right. And it's not too bad at all. Okay, so for this first one, everything again is going to be done on the polar grid. You need actual polar grid. All right, not a ghetto polar grid that you draw it yourself. All right, let's be real here and do it on an actual polar grid. Okay, so for the first problem here, I'm asking you to graph r equals 5. Now, if you remember from our work in the second part of the second third of this unit, the r value is the distance from the pole. Okay, so no matter where I go on this grid right now, the distance from the pole will be 5. So let's say I'm at 0 degrees right here. The distance from the pole is going to be 1, 2, 3, 4, 5. There's my point. Well, hey, what about if I'm at pi over 12? Distance from the pole is still 5. 1, 2, 3, 4, 5. What if I'm at pi over 6? It's still 5. Everywhere you go on this circle, every point should be a distance of 5 from the pole. So as you start filling this in, you're going to notice what shape is starting to form. And you are correct. That shape is a circle. So here is your first graph on the polar grid, which is a circle. Anytime it's r equals a number, you will have a circle. Okay? It just, the number tells you how far away from the pole each point should be. Not too bad, right? Not too bad. All right, let's get a little nuts and go over to number 2, which is r equals -3. All right, now if you remember what the negative value does, remember the first part of this unit, first couple days, what the negative does? So if I'm at 0 right now, and I go 3 away from the pole, because it's negative, you have to go in the opposite direction. So really take a look. It would be 1, 2, 3, that point right there. All right. It's just going in the opposite direction. Now, what happens when I graph the point at pi over 12? All right. Well, you go 1, 2, 3, but we're going in the opposite direction. 1, 2, 3. All right. Let's go all the way up to pi over 2. 3 units away from the pole, but in the opposite direction. 1, 2, 3. Okay, I might have gone 4 there. I can't tell if there's this little mini circle in there, but that's fine. I'm going 1, 2, 3 that way. Okay. So again, no matter where you go. All right, let's do one more here. Let's go from pi. 3 units from pi, but you got to go in the other direction. So where are you guys going? 1, 2, 3. And as you guys start noticing the pattern, hey, we're going to have another circle. Okay, we're going to have another circle drawn here. Again, like I said in number 1, anytime it's r equals a number, you're just going to have a circle. Okay, so r equals any number is going to be a circle. All right, that's not going to be, I wish it was that easy and saying we're done, but we got some serious dealings right now. What does 4 cosine theta look like on the polar grid? We used to graph these back in the day. Yeah, we graphed these back in the day on the XY grid. Remember, we would say up 4 is the amplitude, so we start at 4. Remember, this goes to its minimum, or goes to the 0, goes to the minimum, back to 0, back to the max. Remember those good old days, face to face, when I enjoyed some of your company? But okay, what would this graph look like on the polar grid? That's what it looks like on the XY grid, but what would it look like on the polar grid? So what we're going to have to do right now, until we can find out a pattern in the next couple lessons, is fill out a chart. All right. So at 0 degrees, what point am I going to plot? Well, I need to plug in 0 for theta. Okay. And everything is in radians, remember. So what I need to do first is go to my calculator, make sure it's in radian mode, which it is. Clear it out here. And what I'm going to have to do is 4 times cosine 0. And it's 4. So in this case, the r value is 4. So the point I would plot would be 4, 0. Okay, so I go over to my grid at 0. I'm going to go out 4. 1, 2, 3, 4 right there. Okay, let's keep going. Let's plug in pi over 6. So 4 times cosine pi over 6. Gonna need a fraction template. Pi over 6. Let's see what that's going to be. That's going to be about 3. I'll say 3.5. We'll round to the nearest tenth, okay? So r equals 3.5. So the next point I'm going to graph is 3.5, comma, pi over 6. So at pi over 6, and I'm not looking for greatness here, but at pi over 6, I'm going to go 3.5 units away from the pole. So it's going to be, let's see, my eyes always, this messes up my eyes. 1, 2, 3.5, about right there. Okay. So, and I keep going through this right now. I keep going through this. So I'll keep going with you. No big deal. So 4 cosine pi over 3 now. And 2. So r is equal to 2 here. So I should have 2 comma pi over 3. So at pi over 3 now, I'm going over to 2. 1, 1, 2, right there. Okay, 1, 2. All right, next up, what's up next? Pi over 2. All right, same thing. If you guys want to go ahead of me, you can go ahead of me. I'm okay with that. And that's going to be now pi over 2. And I get 0. So I'm going to plot 0, pi over 2. So where would that point be then? That point's going to be back at the pole. All right, let's keep grinding. 4 cosine. This is the longest part, is just plug it in your darn calculator. 2 pi over 3. And I get a negative 2 there. All right, so now we got to talk. R equals negative 2. So I would have negative 2 comma 2 pi over 3. All right, so where 2 pi over 3 is, right here, because it's negative, the R value is negative 2, we just went over, you got to go on the other side. All right, you got to go on the other side of that. All right, so let's do that. So negative 2, so that would be 1 about right here. If I lined it up on the direct opposite side, negative 2, 2 pi over 3. Everyone see how that point's graphed. Watch out for the negative R values. Okay, keep grinding. 4 cosine 5 pi over 6, negative 3.4. So R equal about negative 3.5. I was going to round. So negative 3.5 comma 5 pi over 6. Okay, go back to the graph. So at 5 pi over 6, I'm going to go about negative 3.5. So let's see, 1, 2, 3.5, about right there, I guess. All right, not looking for greatness. All right, we're almost there. What's up next? Pi. So 4 cosine of pi, negative 4. So R equals negative 4. So I'm at negative 4 pi, and here we go. Now we're going to start noticing something. I'm at pi right now, but since the R value is negative, I go on the opposite side, and look where I am. Right here, I've graphed that point already. So now we're starting to get a little repetition here. Let's see what happens as we continue. 4 cosine 7 pi over 6. Negative 3.5. All right, here we go. So R equals negative 3.5. So my point's going to be negative 3.5 comma 7 pi over 6. So I go 7 pi over 6. If you guys go on the opposite side, what do you see? We've already graphed 3 because I got to go on the opposite side because the R value was negative. and that point's already there. All right, and I'll finish this up right now. I've already done this, but this will be r equals 0. So it'll be 0, 3 pi over 2, already graphed that point at the pole. And then at 5 pi over 3, r equals 2. So you have 2 5 pi over 3. And if you guys take a look right now, go to 5 pi over 3 and go 2 units out, we've already graphed that. So right now, that is our graph right there. Okay, it is another circle, much smaller and moved. There's my graph for that one. Okay, so you are going to see circles here. All right, it's just a matter of where they are. Like if I change this cosine to sine, the graph's going to get affected, and you'll see how on the assignment. Okay, it's just because it's cosine. I'll talk about it hopefully at a Google Meet. What happens when it's cosine versus sine? You guys noticed that the number out in front was 4, and how far did it go out? At 0, it went out to 4. Okay, so there are little patterns here, but to be on the safe side right now, you guys just stick to the table. Okay, last thing I wanted to show you here, and this is how you can check your work to make sure you are correct without even having to go on Aspen and checking my homework answers. What you can do, all right, and I'd really like you guys to take advantage of this right now. So if you can, if you're on your Chromebook, you can just listen to me, open up a new tab, all right, and go to the following website, which we're going to be on a lot at the end of this unit here. Desmos, DESMOS.com, Desmos.com, DESMOS.com. Okay, and I'll follow you through right now. All you need to do is start graphing. There's no need to sign up for anything. It'll do these graphs for you. You type in the equation, and it'll do the graph for you so you guys can check if you're right or not. All right, but the first thing you want to do before we start graphing is notice right now we're on a rectangular XY grid. You want to change that to a polar grid. And the way you do is you go up to this little wrench up in the top right-hand corner, and then you'll notice where it says grid. Right now, the rectangular grid is highlighted. You want to highlight the polar grid, and look at that bad boy that pops out. Okay, it's already there for you. And then you can just click out of that. And now right up here on number 1 is you can start graphing these. So the first problem we had to do today was R. So you can type R equals, you just go equals 5. And look what happens in red. There's the circle we just graphed 5 units away from the pole. What about the second one we did? R equals -3. Boom, it's right there for you. All right, now what about the last one? Ready? 4 cosine, COS. Now I got to do a parenthesis for the theta. Anytime I do theta, I got to put it in parenthesis. Now, how do I put the theta in there? You literally type in the word theta, 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 and it'll pop in there for you. And look what it is. Looks pretty familiar, doesn't it? From what we just graphed. A little bit smaller on ours because this is blown up, but yeah. So this is a way you can check. All right, so after you're done graphing, head over to Desmos and graph it away. All right, this is awesome. All right, it'll make sure you do the correct graph every single time. Okay, so hopefully you guys will take advantage of that. All right, guys, I know I'm laying it on thick here. A solid 3 graphs. Wow, 3 graphs. Get after it.